As humans, we perceive the world through our senses. We see how we can grab an object like a hammer. We can smell fire from far away. We can taste if food is ripe and ready to eat. We hear a car coming and feel that it's cold. These are our five senses: sight, hearing, touch, smell, and taste. As humans, we use a lot of products like cars, phones, and computers. These products have senses too, only we call them sensors. Sensors like temperature sensors, pressure sensors, and light sensors. That's how a product like an automatic door knows when you want to pass through it. But wouldn't it be great if these products could really know what we want to do? A phone that knows you're in a meeting and silences itself. A car that helps you look for a big enough parking spot. A computer that knows exactly what you want to do and helps you to do just that. To do this, products need a range of sensors and very clever designs. More and more, very cleverly designed products use a range of sensors to know what we want to do and become better products for it. Cars that see a pedestrian and brake automatically if you don't do it in time. Game consoles that know how you want to hit that ball in the virtual game of tennis. And health measuring devices that alarm a doctor when needed. But making these products know is something not a lot of people can do. A machine can measure lots of things with different kinds of sensors. But adding meaning is the real tricky bit. You need very smart people for this. That is why the Hansa Institute of Technology in Assen, the Netherlands, started a new study called Advanced Sensor Applications Bachelor Program. In this 4-year study, you learn everything you need to learn to make products know what we want to do with them. Learn more at hit.hansa.nl.
Okay, there's a slide, a brief introduction of what a sensor is. But for today's lesson, we will focus on a specific sensor to control our LED. Okay? Just by the show of hands, does not have overshift. 2, is it? Only 2. Okay. Can everybody turn to page 2? Going to study more about this thing called a light-dependent resistor. A light-dependent resistor, as you see the diagram, is a type of sensor which responds to light. Okay, I'm not sure whether you have seen this, but have you seen a light bulb? Not light bulb, you know those wall light, whereby when it turns dark and then automatically the light will turn on. And then when it's bright, meaning in the daytime, it will switch off. Have you seen such lights outside the house? Okay, those are how, okay, in the general form, that is how it looks like when it's dark. Your HDB flat, the light will turn on, right? And then when it's bright, in the daytime, it will turn off. It works in the same principle, but for the HDB one, they use a timer, which they don't use a sensor, okay? But this LDR is a sensor which detects the amount of light. Ignore the Batman for the time being. I'm not sure why it's there. Anyway, a light-dependent resistor, or LDR, the resistance changes with light. Even so, it's a sensor. It operates on a resistance which is dependent on light. So in short, when it is bright, it is high resistance, and because it's high resistance, your light will turn off. Bright, it will off. When it's dark, it will turn on. Clear so far? You can imagine the LDR as Batman, because Batman, he stays awake at night, and in the day he sleeps. Okay? So LDR does just like that. Later on, I will switch off this light to illuminate dark, and then you'll try to make your LED light up. Okay? Next is this thing called the command called analog read. If you look to page 2, when I was marking your paper, some of you or many of you do not circle your response or indicate your response. Okay, I just want you to indicate the response. I make the worksheet very easy for you already. Analog read, you will use analog pins. Analog pins is from A0 to A5. So you will no longer, you cannot use an analog read command with a digital pin, because it's analog. You use analog pins. Okay, later you'll see how this works. Okay, let's get started with the connection. Like your switch, you will need to use 2 resistors. Okay, your 220 will go to your LED, and your 10 kilo ohm will go to your LDR. Yeah. Okay, 220 ohm, which is red brown, goes to your LED, and your 10 kilo ohms goes to your LDR. If you turn it around, your LED will become very dim. So this is how the connection is. You are using 220 ohm for the LED I mentioned just now, and LED is connected to pin 8. Your LDR is connected to A4, and then you use 5 volt and ground. Okay, this is a schematic. Can we get started? I will go around and... Okay, wait. Once you are done, I want you to load the sketch. The sketch can be found in your D drive, lesson 4. Open the file called threshold. Okay, open the file called threshold. It's in your D drive. Today, no need to type. Let's get the diagram. Let's get started.
Sorry, I accidentally show the camera at you.
It doesn't matter.
So go what?
What?
Go what?
What?
In your mind.
The long one?
Okay, you can go to page 3 for your connection if you do not want to look on the board.
I need help. Do what? Do what? Do what?
You need to do like that.
No need type, teacher already say. Oh, pick which one?
Let's go.
Yes.
He got smashed.
After this, do what? just want to know the type. I always check for.
Maybe to leave it.
Okay, just
I think
leave it.
you can find it somewhere.
Yeah, where?
Close it. Go computer. Yeah. This is lesson.
4.
Yeah.
Auto light.
Threshold, yes, threshold.
Okay,
Give me a bit.
for those of you who are really connected, I will
I have
show
over there.
you something that you need to do first before you will see something happening. Okay, for those of you who are connected, right? If you look at your Arduino app, there is this thing called there's this magnifying glass over there. Okay. Now, once you're done, I want you to click on this magnifying glass. This thing has a name. It's called the serial monitor. What it does is it shows the values of your LDR on the screen. After you've uploaded, it will show the value of the LDR on your screen. Typically, your LDR value should be about 900, 800 in a bright light like this. Okay, you'll see a set of running values.
Nana, say hi.
Lu mau kecil.
Nanti buat upload.
Wait.
Nanti buat upload. Why?
Wait.
Lagi in. Yes, it's wrong. I will upload. It will not turn on yet until the light is off.